Okay, barium hydroxide reacts as we've got here. And the first question says, which row shows the state symbol? So if we remember, S has got to be solid. So barium hydroxide is not going to be that one, not going to be that one. They're rubbish. HCl is aqueous. So we've got solid and aqueous for HCl. So that one is wrong. So the only right option is option A. And just to check, this one is aqueous, which it says here, and this one is a liquid, which it says here. So that's the first one. Okay, the student wanted this investigation. This is one of the core practicals we did, and they're adding the solid to the liquid. And it says describe how they could more accurately measure the volume of the hydrochloric acid, something better than a measuring cylinder. So a better way than using a measuring cylinder would be to use a burette. That's the device we used when we were measuring volumes in a titration. Describe how the pH of the mixture is determined when a drop is placed on a universal indicator paper. So what you would do is you would observe the color, the paper changes, and then what you would do is match the paper against a color pH chart. You would then find the actual pH value. The method universal indicator is used. Explain why litmus would not be any good. So litmus wouldn't be useful because litmus would only tell us if it was an acid or alkali. So it only tells if it's acid or alkali. It would not tell us the actual pH. So it wouldn't say it's pH 9, for example. It would only tell us that it is acid or alkali. So you get 1 mark in there for that line and a second mark for that line. Same with this one, I should have put that on. So 1 mark there and 1 mark there. Okay, carrying on. We've got a pH set of data, so pH for each one of these, and it wants us to plot this data on a graph. I've actually done this already, so you can don't have to watch me doing it. But marks wise, you are going to get a mark if the axis, so both axes are nice linear scales. So that means they go up in a steady pattern. So you can see every large square is 2, 4, 6, 8, and here we've got 0.2, 0.4, 0.6. So I get 1 mark here for the axis being nice and linear. I get another mark for the points that I've plotted, them being correct. So 1 mark for the points correct. And a second mark if the graph covers over half the page. So the graph covers over half the page. Okay, so 3 marks, and that's how you get the marks for that question.